Okay, how's it, Chase? Today we're carrying on with section 5.21. 5.21. And that is amplitude and frequency. Okay, so amplitude is the height of a wave, while the frequency is the number of times it appears in a certain period of time. So, for example, if we look at a sinusoid, okay, and assume this is 360 degrees, okay, the amplitude is this height here on the y-axis, okay, that's the amplitude. So this could be like, for a normal one it would be 1. Okay, the frequency is the number of times that the wave repeats in 360 degrees. So in this case, it only repeats once in 360 degrees. So it has a frequency of 1. If it looked like this, then you'll see we've got 2 repetitions of the wave in 360 degrees. So it would have a frequency of 2. So basically, if you want to talk about repetitions, it's basically the number of ups and downs divided by 2. Okay, so if it goes up once and then down once, that is 1 repetition. And up and down again, that is 2 repetitions. And if we did something like this, say that was 360 degrees, then we've got one full repetition and a half repetition, so it would have a frequency of 1.5. Okay. Okay. Alright, so example 35. Example 35 says, okay, so we're going to do this. They don't give any specific method for doing it, so you're welcome to just do it on your calculator. Pop the values into your calculator using the table feature. I'm sure you know how to do that by now. And, sketch all 3 graphs. You probably want to do at least steps of 30 degrees, maybe 45, maximum of 45. Especially for this one, and you'll see why now. So let's start. Let's draw an axis system. Should actually get a ruler, it would really make this easier. Okay. So let's go. That's 1, 2. It's our y-axis. Here is our x-axis. -1, -2. Remember that the sinusoids, all the trig functions do extend into the negative side as well. We've just been drawing the positive sides of them. 30, 60, 90, 120, 150, 180, 180, 210, 240, 270, 300, 330, 360. Okay, so I'm not going to do the calculator because I know how to draw these without using the calculator, but you should pop these values into your calculator and actually plot them using the calculator. So, because it's a sine graph, we start here at 0. Okay, then at 90 degrees we have to be at 1. At 180 degrees we cross 0. At 270 degrees we're going to be at -1. And then at 360 degrees we're going to be at 0 again. Okay, and there you go. So there is the graph y equals sine x, and I think you label it when you draw something like this, y equals sine x. Okay. Next we're going to draw y equals 2 sine x. Okay, and we'll do that one in green. Y equals 2 sine x. So once again it's a sinusoid, so we start at 0, 0. Then it's exactly the same as the sine graph, except so it's the same as the red graph, except all of the values are multiplied by 2. So at 90 degrees we're going to be at 2 instead of 1. Then we're going to cross here at 0 again. And we're going to cross, we're going to be at -2 at 270 and then 0. So y equals sine 2x just looks like this. Okay, so you can see that it's all of the values are just doubled at each point. That's all that's happening here. Once again, pop it into your calculator and get the table. Now while we're doing this, there's just a nice tool that I thought of. I wonder if I've got it at the moment. A very nice tool for you to check all of these things very easily. I'm actually just going to quickly install it and show it to you. Okay, so the program is called Microsoft Mathematics 4. It's a useful little tool. It's obviously not going to help you in your exam, but what it will help you with is just your general studying. You can use it quite nicely there. So you can download it for free. Let's see if it runs. Just installed it now. So okay, you can download this program for free, and yeah, it's got a lot of useful features. It's basically just like a giant calculator. It's quite nice. Let me just fit it here. Okay, so one thing we can do with this, it's got a lot of functions. It can solve an equation. For example, if we put in x plus 2x squared equals 7. Okay, and you just press solve. There it gives you your two answers, and it even shows you how it got there. So that's quite useful. You can see it can also work with complex numbers. Okay, but anyhow, it can solve quite a bunch of different equations. If you've got a set of two equations, so y equals 2x plus 5 and y equals 2x plus 4y equals 7 and x squared plus y equals 1. It can solve. Well, I'll just put in a set of equations that has no solution, but you get the picture. What's nice, and what I wanted to show you, is that it can do graphs. So we type in the equation that we wanted to plot. So in this case it was sine x. Okay, and then we say graph, and now we need to be careful. You see it's plotted. We're working in, we just need to change our plotting range. So minus 360 to 360, I think, and that should give our answer. Okay, starting to look, and also our y scale. Let's plot from minus 2 all the way to 2. Okay, and there you go. So there's your graph of y equals sine x. Now we could do our graph of 2 sine x, 2 sine x, and we say graph. And once again, it changes the plotting range. I don't know why. You need to fix that. I have no idea why it does that. There should be an auto. I really don't know why it decides to do that. Yeah, I really don't know why it always changes it. But if we set our plotting range correctly, minus 360 to 360. Oh jeez, what did I do? Minus 360 to 360 on the x-axis, and we want to plot from minus 2 all the way to 2 on the y-axis. And there you go. So there you've got your, so you can see, and you can even, I think, trace points somehow. I can't remember, I haven't used this in a long time. But there you go, there's your sine graph. There's your trace. So you can run a trace and check all the values as you go along, which is quite cool. And then you can pause it and actually move it manually and trace the values of your graph. So as you can see, if you look at this point here where x is close to 90 degrees, y will be 1. And then if we look on our other graph, we trace our other graph, and we look at that point, there y will be 2. And it'll be the same way, like the 2 sine x graph will always be double the sine x graph. And then if we want to plot our last one, we can plot sine of 2x. Plot that one. If we zoom out far enough, it's easier just to set the plotting range correctly. I don't know why it's making so many mistakes with the plotting range, I have no idea. Okay, so there is our graph. The purple line is the graph of sine 2x. So can you see that it's got the same amplitude as sine x? Like, look there, same amplitude, the peak is 1 and the negative peak is -1, but it's got twice the frequency. So you see, for every time, so that's the effect of this 2 here. Every time the sine x graph goes up and down once, you'll see that the sine 2x graph goes up, down, so it goes up and down twice. Okay. So yeah, that's okay. So yeah, you can use this Microsoft Math. Like, I don't recommend, like, it doesn't have much value because you can't take it into a test. But like, if you're unsure how a graph looks, or how you know, how what the solution of an equation is, or whatever else, you can, you know, you can try use this as a tool to help you get the answer, and then figure out you know, how to get there by yourself. So yeah, that's just the tool I wanted to show you. So now it's kind of pointless because we've already seen what happens, but I'm just going to quickly draw y equals sine 2x. Okay, so let's draw that one. So y equals sine 2x is exactly like sine x, except it's squished. Like, it's squished, so all the points are going to be half the distance that they were at. So instead of being sine 2x, instead of being 1 at 90 degrees, is 1 at 45 degrees. instead of crossing 0 at 180, it crosses 0 at 90. Okay? Instead of being minus 1 at 240, it's going to be minus 1 over here at 150, I think. And then it's going to cross 0 again at 180 and repeat. So there it's going to look like that. And it's going to carry on. Okay. So there you go. There's y equals sine 2x. So the question asks, observe the effect of the 2 on each curve. So basically, with trig functions, the 2, so here is your standard sine, and this applies for the standard cos and standard tan. Okay. The 2, or the number in front, so let's do this. Y equals a sine x, a sine bx. So the a affects amplitude. So obviously the bigger a, the higher the peaks are going to be. The smaller the a, the lower the peaks are going to be. And b affects frequency. So b equals the number of repetitions in 360 degrees. So you see here we had sine 2x, so the graph it repeated twice in 360 degrees. There's the first repetition, and there is our second repetition in 360 degrees. Okay, a repetition is an up and a down. Okay, cool. And the frequency is always measured as number of repetitions in 360 degrees. Alrighty. Alright, so let me just get us a blank page here. They also talk about converting angles to radians on page 548. So I just want to show you that degrees, or rather let's do this, radians equals 2 pi times degrees over 360. Okay, so if you have, say, 360 degrees and you want to convert that to radians, or let's do 180 degrees, and we want to know how many radians that is, we put it into this formula. So 2 pi times 180 over 360 equals 2 pi times 1 over 2 equals pi radians. Okay? And you can obviously also solve this formula for degrees. So if you're given pi radians and you want to convert it to degrees, we just use this formula again. So we say pi radians equals 2 pi times degrees over 360. We solve for degrees. So pi over 2 pi equals degrees over 360, and degrees equals 360 times 1 over 2 equals 180 degrees. So that's how you can convert between degrees and radians. It's pretty easy. So just be careful like what mode your calculator is in, whether it's in degrees or radians, because you mustn't make the mistake of doing a table thinking you're doing degrees and then you're actually in radians and so on. So if you're using degrees, make sure your calculator is in degree mode. Example 36 says, draw the graph of y equals 2 sine x for values of x between 0 and 360 with intervals of 30. So all you have to do is, make a table of, so you're going to make your table with x and y, and we know y equals 2 sine x. And then intervals of 30, and they say between 0 and 360. So for x between 0 and 360 degrees. So we just go, we make our nice table we go x is 0, 30, because they said intervals of 30, 60, 90, 120, so on, blah 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 blah, and then we can calculate our y values and put them here, and then we can draw our graph. We just draw the ordered pair on our Cartesian plane, or you can make the table on your calculator. Just remember that your calculator can only calculate 10 points. So 1, 2, 3, 4, 5, 6, 7. I'd recommend you break it up into 0 to 180. Do it on your calculator using the table mode, and then again do 180 to 360 on your calculator. That's how I would do it. Okay. Alright, so now there's one more thing that can happen with these trig graphs, and that is a shift. Okay, so I'll give you the full general form of a sine graph. Y equals sine, y equals a sine bx plus c. Okay, so we've already determined that A is the amplitude, which is how high the maximum point is. Okay, B is the frequency, or number of repetitions in 360 degrees. Okay, and C is the middle line on the y-axis. So to explain that properly, I'm going to draw y equals sine x, okay, and then I'm going to draw y equals sine x plus 1. Okay, so for this graph, from our general form, we already know that the amplitude is 1, the frequency is 1. Okay, so let's draw our quick sine graph. So our sine graph starts at 0, bam, bam, and there's 360 degrees. So what does this plus 1 do? It just lifts the whole graph up by 1 on the y-axis. So this point is at height 1. This point is at line at height -1. Okay, so lift the whole graph up by 1. So let's do that. Okay, so instead of starting at 0, where does it start? We start at 1. Okay, then instead of going up to 1, we're going to go up to 2. Then we're going to go down and cross the 1 line. And then instead of dropping all the way down to -1, we just drop down to 0 and then back up to the line 1. Okay, you see that? So basically that plus 1 just shifted the whole graph up. Every single point got shifted up by 1. And once again, you can just pop this into your calculator and you'll have your, it'll give you the points. And just to show you in Microsoft Math here, we'll plot the graph for you. So let's quickly go graphing. Okay, so we're going to plot sine x and we're going to plot sine x plus 1. Okay, and we're going to graph it. We change our plotting range. X is -360 to y is 360, and y is, we're going to go from let's do -2 up to 2 and plot. So you see here is y equals sine x in the blue and y equals sine x plus 1. It's just everything shifted up by exactly 1, and that's all that happened there. Everything is just shifted up by 1. Okay, so now we know that here's the amplitude, which is, the amplitude is this. Okay, so now one thing to be careful with amplitude is measured from the middle line up. Okay, it's not measured from 0 up. So the amplitude is measured from this middle line here. So the amplitude of this graph is still 1, even though the highest point is at 2. The amplitude is still 1, because it goes from 1 up to 2, so amplitude is 1. Okay, amplitude here is also 1. Okay, we know that B is the frequency, which is the number of times that the graph repeats itself in 360 degrees. So in 360 degrees, both graphs have gone up once and down once. So it's only repeated itself once. So the frequency is 1. As you can see, B is 1, so the frequency is 1. And the C is the translation upwards, and as you can see, we've lifted for the second purple graph, it's been lifted up by 1. Okay. All of the same rules apply for cos, by the way. So if you had, y equals a cos b x plus c, this is still the amplitude, this is still the frequency, this is still the translation. So if we draw this guy, cos just starts here. But as I said, you can just put all of these into your calculator, and if you know how to use your calculator, it'll give you all the points on the graph. So cos just looks like that, where that is 360 degrees. Okay. It's also from 1 to minus 1. Minus 1. So it has an amplitude of 1. It has a frequency of, it goes down and up. Okay. So it only repeats itself once. So it's once again here we've got a frequency of 1. And C in this case is 0, because the middle line is at 0. Okay. And all the same rules apply. If C was 1, we would be here. And that would be 2. And our middle line then would be at the line 1. Okay, so that would be if we increase C to 1. If we increased B, then obviously we would have increased the frequency, and you'd end up with that, with 2 repetitions of the graph. And if we increased A, of course, then instead of us starting at 1, we would start at 2, drop all the way down to minus 2, come all the way back up to 2. Okay. So if you're not entirely clear about these, play around changing these parameters in Microsoft Math, and you can see how the graphs look. And you can also just plot a whole bunch of different ones on your calculator. Your calculator can plot all of these graphs, no problem. So yeah, it shouldn't be a problem if you're asked to sketch, you can type it into your calculator using the table mode, and plot your graph, because it'll give you the pairs. Okay, so let's see what the next question is here after I've got us a blank page. Open. No. Okay. Okay. So now we've got example 40. Draw on the same system of axes the graphs y equals 2 cos x and y equals 3 sin x minus 2, and solve the following equations from the graphs. Okay. This is quite interesting. I'm definitely going to do this for you. Okay. Okay, so the question says, nah man, come on. I'm trying to get my white pen. It's not working. There we go. Okay. Draw on the same set of axes y equals 2 cos x and y equals 3 sin x minus 2. Okay, so that's the first part of the question. So I'm going to draw it freehand for you quickly. I'll try my best to make it neat. I'm assuming they want it plotted between 0 and 360 because they don't say. So I'm just going to plot at 45 degrees, 90, 135, 180, 225, 2... My maths is letting me down here. 65, 270, 315, and 360. Okay. 1, 2, 3, minus 1, minus 2, minus 3. Okay. So y equals 2 cos x. As I said, put this into your calculator and actually put your x points, so 0, 45, blah, 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 blah. Put in your x points, okay, into your calculator, and then get your y points. So do 2 cos x, and then also do y equals 3 sin x minus 2. Get the table, generate the table using your calculator. Obviously you'd have to do them separately, and you'll get your y values, and you put these points onto the graph and then sketch them in, okay? And this needs to be an accurate sketch because the problem's asking you actually to use these graphs to solve equations, and I'll show you how to do that now. Okay. So let's do it. So once again, I don't really need these points because I'm experienced at drawing these things. So cos x is going to look like this, or 2 cos x is going to start at 2. It's going to end at 360. It has axis crossings there, minus 2 here, and then it's going to be at 0, and we're going to end at 2. So 2 cos x is going to look something like this. Okay, you're going to have to generate a few more points. You're going to have to be accurate because you want to use these graphs to solve equations, so you need to be accurate. The next is the graph 3 sin x. So it's a normal sine graph, except the amplitude is tripled, and then it is shifted down by 2. So usually with the sine graph we'd start at 0, but it's shifted down by 2, so we start over here. Okay, then usually your graph would go up to a sine graph goes up to 1, but this is tripled, so it goes up by 3. So we're going to go, and it's going to reach that peak at 90 degrees, and that peak is going to be here. Okay, then we're going to come down at 180, up, down, and going to end over there. This is also not that nice because my spacing is not very good. So we start at minus 2 because it shifted down 2, and it's a normal sine graph, so it would usually be at 1 at 90 degrees, but here we're going to move up by 3 from our starting point. So we're going to go up 1, 2, 3. Then we're going to go down to minus 2 again. Oh no, I lie. Remember, minus 2 is our center line. So let's not be dumb. Minus 2 is the center line of our graph. Okay. So at 180 degrees, we're going to need to put in a couple, minus 4, minus 5. Okay. So at 180 degrees, we cross our center line. So we're going to be there. Then we go below our center line, and we're going to go 3 units below our center line. So 1, 2, 3 and we reach our negative peak at 270, and then we come back up to our center line by 360 degrees. Okay, so there's your graphs. And now I just want to erase here so that we've got a bit more space to work. Not the right color. I want black. Okay. There we go. And let's switch back to a pen. And we're going to write in white. Okay, so now they say solve the following equations. A, 2 cos x equals 3 sine x minus 2, and solve 3 sine x equals 1,5. Okay, so they're saying use the graphs to solve this first equation. And it's nice because we've already got these two graphs plotted. So where are they equal? It's the point where the y's are equal, which is the points where they cross. So there is a crossing point, and there is a crossing point. Okay. Because that's where the graph of, what was this? This is 2 cos x, and this one is 3 sine x minus 2. So can you see that these are the points where those two graphs are equal? It's the points where they cross each other. So what is the solution? Well, let's go figure it out. Okay, and this is why I said you're going to have to be accurate, because you're going to have to do this. You actually have to so you need to get that angle through measurement on your x-axis. So that is round about what's between 90 and 45. I'm going to say that that's about 70 degrees, maybe 75 degrees. And over here, where are they equal? They're equal at around I think that is actually 180 degrees. They're equal that. It's just a bad drawing. But they're equal at 180 degrees. So this equation is true when x equals 70 degrees or x equals 180 degrees. And if I compare that to the answer in your book, they said 67 degrees and 180 degrees. And you would get the mark most likely, no matter like for saying 70 degrees, because remember you're now reading off a graph, so you're not going to be that accurate. So I hope you understand that method. I'm going to run through it one more time actually. Okay, B, 3 sine x equals 1.5. So here's the problem. We've got the graph 3 sine x minus 2, not the graph of 3 sine x. But if we okay, so we've got the graph of 3 sine x minus 2. So how are we going to solve that one? Well, we're going to solve it with a nice little trick. Okay, they're asking us to use this graph that we've drawn. They're very specific. They're not saying draw a new graph. They say use this graph. So we can do something interesting to this equation. What if I just add 2 to both sides? 3 sine x plus 2 equals 1,5 plus 2. So we have 3 sine x plus 2 equals 3,5. Should be 3 sine x minus 2, sorry. My bad there. 3 sine x minus 2 equals 1,5 minus 2. 3 sine x minus 2 equals 1,5 minus 2 is negative 0,5, right? Yeah. Okay. So now, do you see that I haven't changed the equation by taking this minus 2 because I put it on both sides. So it cancels. Because if I take that minus 2 across, it'll be a plus 2, and so it cancels. So you can do anything on both sides of the equals. So now, it's nice because now I know I've got 3 sine x minus 2 equals minus 0,5. So now, I just draw in the line minus 0,5, which is round about here. Do it with a ruler when you're doing this type of thing in a test. Okay, so where is the graph 3 sine x minus 2, my green line, equal to minus 0,5? Well, it's equal over here, and it's equal over there. So we just quickly read off our graph there, and there. And to me that looks like about 30 degrees and 150 degrees. As I said, you're going to have to be more accurate than me here, because I can't sit with a ruler and measure this, but you can. So there you go. And we've used our graph to solve our equation. What does your book say? Your book also says 30 degrees and 150 degrees. So that's like the graphical method of solving trig equations. And it's actually quite nice because I'd forgotten that you could even do it this way. So now I'm going to show you just on Microsoft Math. I'm going to show you the same thing. So let's plot our graphs again. So the first one was, where is it now? Our first graph was 2 cos x. 2 cos x. Our second graph was 3 sine x minus 2. Don't forget your brackets if you do decide to use Microsoft Math. And as I said, just remember, Microsoft Math is just there for you to help you learn and to like check your work. And we're just going to plot from 0 to 360 on the x-axis, and we'll plot from minus 6 all the way up to 2. Okay, and there's your graphs. As you'll see, it looks quite similar to what I drew, just a lot nicer. So once again, the points where they equal are there, this point right over there, and they're also equal at that point over there, right? Okay, so how would we, we can read it off the graph. We can read our x value where they're equal off the graph by zooming in, if that's the way you wanted to do it. You can zoom in really closely and you'll see you can get quite a nice reading there. See, it's between 66 and 68 degrees, so that's about 67.5. Or we could use the traces. Remember I showed you the trace. Where is it now? Oh, here. Go graph controls, trace. Okay, and then you can pause it and you take that thing right to the point where they're crossing. And you see there, x equals 67.5 degrees. So that's your answer, because that's the point where the two graphs are equal. It's the point where they cross. And then we can do the other point, which is right there. Which is 180 degrees. That's the point where the two graphs are equal, because that's the point where they're crossing. That second part, where we had to have, where they asked us to solve 3 sine x equals 1.5. In order to make this left hand side look like that, we just took minus 2 on both sides, and we have 3 sine x minus 2 equals negative 0.5. So we can just plot the line of negative 0.5 here. So we just plot minus 0.5, bam, and we graph it. If I can find my mouse. Okay, and once again you've got to change your plotting range, because this thing is annoying sometimes when it wants to be. Okay, so there's our line minus 0.5, the little purple line. So you can see that that is equal to our 3 sine x minus 2 graph over there and over there, because that's the points where they cross. It's also equal again there, but that's past 360 degrees, and we are only working up to 360 degrees. So once again, we can zoom in there and read off the value, or we could use a trace. So let's just zoom in and read it. So that is 24, 25, 26, 27 degrees over there, more or less. You can zoom in closer the more accurate you want to be. Or as I said, you just use the trace. Okay, it's actually 30 degrees. There you go. 30 degrees. That's where they equal. And if we zoom out, we go look at that point. Zoom in nice and close on it. I'm just using my mouse wheel to zoom, by the way. You just scroll in. And you can see those two are crossing at x equals 150 degrees. So yeah, there you go. And there's a nice zoomed out view showing you how these graphs just carry on forever. Okay, I hope you understood that. It's a bit of a tricky one. As I said, trig is the weirdest thing to try and explain. Like, it's a difficult thing to explain, especially when you're not in person. But I hope that helped. And yeah, I'll see you again next time. I think, please tell me we're almost done with this chapter 5. There's still quite a bit to go. No, not really. Hey. I don't think there's actually that much to go. No, there's not. Okay. I feel like in the next video we're going to finish off chapter 5. And then it's just, I think, integration and differentiation. Yeah. Differentiation and integration, and then we're done. So yeah, that's great news. Anyway, thanks for watching, Chase. Cheers.